Alright class, so let's continue with the rest of our basic differentiation uh, lecture. And if we take a look at this problem, we have the constant multiple rule, we can use the power rule, we can use the constant rule, and we can even use the sum and difference rule. However, the one thing getting in our way is the fact that all of this is over the denominator of 3x cubed. Well, what we're going to do is we're going to rewrite this so that if we rewrite it, we can actually use the 4 basic differentiation rules in an easier manner. So if I rewrite this, we have g of x is equal to 2x to the 6th over 3x cubed minus 6x cubed over 3x cubed plus 3x squared over 3x cubed minus 4x over 3x cubed plus 9 over 3x cubed. Okay? And just as a reminder, when I'm using exponents, if I have one term divided by another term, I can subtract the exponents by doing the numerator minus the denominator. So we're going to do that for all of these. And if I simplify this, I get 2 over 3. X, 6 minus 3 is 3. Over here, these x cubes cancel and I get minus 2. Here, the 3's cancel and I get plus x. 2 minus 3 is negative 1. And the next term is 4 over 3. X to the 1 minus 3 is negative 2. That's my negative. Plus, and I'm going to get 3. And instead, I'm going to move this power up here. So I get x to the negative 3. Okay, now I'm ready to take my derivative. So let me scroll down so that we can make room for this. So to take my derivative, I'm going to get f prime of x is equal to 2/3 times 3. My denominator cancels and I get 2x to the 3 minus 1 is 2. This is a constant, so the derivative of every constant is 0. So I'm going to continue here to negative, let me go back. I'm going to continue, and I have negative x to the negative 2, because negative 1 minus 1 is negative 2, plus 8 over 3 x to the negative 3 minus 9x to the negative 4. So the last thing that I need to do is just to make sure I can get rid of my negative exponents by placing them into the denominators. So to simplify this, I get f prime of x is equal to, 2x squared minus 1 over x squared plus 8 over 3 x to the 3rd minus 9 over x to the 4th. And this right here is my derivative once I rewrite my function, and then these my derivative rules. Okay? So let's continue to a problem like this. So not only are we to find the derivative, but we have to plug in numbers to see what the derivative is actually going to equal. And once again, just as a reminder, the derivative is the slope of the tangent line at a certain point. So let's first find these derivatives. And as you can see, I have this radical x. So I'm going to rewrite this so I have an exponent. It gives me f of x is equal to x to the 1/2 minus x to the 2 over 3. And now I'm going to take my derivative. So I'm going to do f prime of x is equal to 1/2 x to the 1/2 minus 1 is negative 1/2 minus 2/3 x to the 2/3 minus 1, which is negative 1/3. Now once again I'm going to take my exponents, and I'm going to move them to my denominators, and then I'm going to change them to their roots. So I get f prime of x is equal to 1 over 2. X to the 1/2 is the same as radical x, so I'm going to put in my denominator. So I get an x right here. Then I get minus 2 over 3. Well, x to the 1/3 is going to go to the denominator, which is actually the same as the cube root of x. And so now what I'm going to do is I'm going to plug in 64 for the first one, and then I'm going to plug in 1 for the second part of this problem. Okay? So if I scroll down right here, and I said we're going to do f prime of 64. So I'm going to plug in 64 every time I have an x, minus 2 over 3 cube root of 64. So if I solve this, the square root of 64 is 8. So I'm going to have 1 over 2 times 8 is 16, minus 2 over 3 times the cube root of 64. Well, the cube root of 64 is 4. 4 times 4 times 4 is equal to 64. So 4 times 3, because of this 3 right here, gives me a 12. Okay. Are we okay so far? Alright, so if I wanted to get the simplified form, I'm going to multiply this side by 3 to get a 48 in my denominator. I'm going to multiply this side by 4 to get a 48 in my denominator. And let's extend this page. So that would give me 3 over 48 minus 8 over 48, which gives us negative 5 over 48. So the slope of the line tangent at x is equal to 64 is actually equal to negative 5 over 48. And I'm going to do this problem again, but instead I'm going to plug in a 1, which is going to make our math even simpler. So we had f prime of 1 is equal to 1 over 2 radical 1. And just to double check, I think it was a minus, yes. Minus 1 over 3 cube root of 1. Well, the square root of 1 is 1, and the cube root of 1 is 1, so this is going to cancel. And I'm going to get 1 over 2 minus 1 over 3. And if I want common denominators, I'm going to get this right here, and I get 3 over 6 minus 2 over 6 gives us 1 over 6. So the derivative when you plug in 1 is equal to 1 over 6. Okay. So you may ask, okay, why do we need to do this? Well, we're going to take it one step further, and we're going to talk about tangent lines and normal lines to the graph. So just from prior knowledge, in algebra we used to use point-slope form, and you're going to use point-slope form constantly in calculus. So as a reminder, the equation of a line in point-slope form is y minus y1 equals m, the slope, but in calculus that's f prime of x times x minus x1. Alright? So when I'm using a tangent line, I'm going to plug in the derivative for my slope. However, when I'm using a normal line, I'm underlining normal line right there, I'm going to use the same equation, except I have to use the normal, or the line perpendicular to the tangent line. And the normal line is the negative reciprocal of your slope. So in here, what I'm going to do is I'm going to do negative 1 over f prime of x times x minus x1. So according to this problem, we already have one piece, which is our x. But for every x, we have to find a y. So let's go ahead and find the y here. And I get y is equal to 2 times 2 minus 1 squared gives us 4 minus 1 squared, which is equal to 3 squared is 9, right? So my y is equal to 9. So to solve these problems, I'm going to have to find my f prime so I can plug it into here, and then take the negative reciprocal and plug it into here. So if I take a look at this problem, as of right now, I don't really know how to take the derivative of that, but the one thing I can do is I can distribute so I can expand this function. So if I rewrite this, I get y is equal to 4x squared minus 4x plus 1, right? So now I'm going to take the derivative of this right here, and I'm going to write dy dx, which is the other notation for derivatives, is equal to 8x minus 4. So I have the derivative, but in order to plug it into here, I actually have to plug in our x. Well, according to this, our x is equal to 2. So dy dx, and here's new notation, when x is equal to 2, is equal to 8 times 2 minus 4, which is equal to 16 minus 4, which is equal to 12. So the slope of the line tangent to the curve is 12. And now what I need to do is plug it into these two equations. Is to plug it into these two equations right here. So I'm going to scroll down and write all our important information in. So what we had was x is equal to 2, we found y was equal to 9, and we found f prime of 2 was equal to 12. So I'm going to plug it in to our two equations up here. So just to keep the colors in, for our tangent line, our equation is y minus y1 equals f prime of x times x minus x1. So if I plug these all in, my y1 is equal to 9, so I subtract 9. My slope was 12, so I plug in 12. And then my x was 2, so I plug in 2. This is the equation of the tangent line to the graph. Now I gotta find the equation of the normal line. So like we said, the normal line is the same thing, except I need to change my slope. Instead of the derivative, it's going to be the negative reciprocal. So I have the same equation, y minus 9 on this side, and I know I have the same x minus 2 on this side. But I need to take this number 12, make it negative, and take its reciprocal. So we do negative, and the reciprocal of 12 is 1 over 12. And so now you have the equation for the normal line to the graph. Get used to seeing these and using point slope form all the time, because it's going to come up in many ways this year. So let's do one last problem. It says determine the point or points, if any, at which a function has a horizontal tangent line. So let's just take a look at what it means to have a horizontal tangent line. Right? So here's just a basic curve. If I draw a point right here, my tangent line has a positive slope. If I draw a point right here, my tangent line has a negative slope. That's not supposed to cross, but imagine that it didn't cross right there. Okay. Well, what happens if I plug it in here and I get a horizontal line that looks like that? What's the slope of this tangent line right here? Well, to get a slope that's a horizontal line, my slope has to actually equal 0. So what we're going to do is we're going to solve for this derivative, and we're going to set it equal to 0, because that's the points where I'll have a slope of 0. So if we do this, we get dy dx is equal to 6x squared plus 6x. Okay. I'm going to set this equal to 0. Well, the easiest way to do this is to factor. So I'm going to pull out a 6x. I'm going to get an x plus 1 and set those equal to 0. So the first one, 6x is equal to 0. That gives me x equal to 0. Second one, x plus 1 is equal to 0. That gives me x is equal to negative 1. And if I read the directions here, it says I need the points. Is x a point? No. A point has an x value and a y value. So what I need to do is plug these numbers into our original equation. Okay? So in order to do that, I'm going to do this right here. I'm going to copy down our equation. Y is equal to 2x cubed plus 3x squared minus 1. So I'm going to plug these in. Let's just extend this page. Well, if I plug in 0, I get y is equal to 0 plus 0 minus 1. It means y is equal to minus 1. So this first point is 0, comma, negative 1. Right? So if I plug in negative 1, I get y is equal to 2 times negative 1. Negative 1 to the third is negative 1. Plus 3 times 1, because negative 1 squared is 1, minus 1. And I get negative 2 plus 3 minus 1. And that gives me negative 3 plus 3, which is equal to 0. So this last point, if I extend this page, is going to be x was negative 1 and y was 0. So I have 2 points, one of which is 0, negative 1, and negative 1, 0. That's it for this lecture. We will take a look at some of this work in class as well as for homework. Thank you.